Okay. So now coming back to rapid gravity filters. Okay. So this rapid gravity filters already now I you know why the slow sand filters are not used and why these rapid gravity filters are being used nowadays. Yes, already the reason you know. So now this rapid like sand filters, they are of two types. Okay, they are of two types. That's number one, where they utilize or they use a comparatively large size sand particles, and also they give a very greater rate of filtration. Okay, so that is known as your rapid gravity filters. And the other one, the next one is like they utilize the pressure, okay, over the filtering water. Okay, so they utilize the development of pressure over the filtering water, and they increase the rate of filtration. So that is your pressure filters. Okay, so now the construction details, I will be showing you the one video, okay, where it is explained nicely all the construction details of rapid sand gravity filters. So now skipping this part, I will be going to one the use of the rapid gravity filters. Like the rapid gravity filters, it's where it is used in a very large towns and cities. Okay, for treating public supplies, and also the as I already told that the slow sand filters, it gives most accurate result. Okay, there it is, the percentage of removal of bacteria in slow sand filters is more than of your rapid gravity filters. But due to some like the causes which I told you, for which the rapid gravity filters are used nowadays, so for that reason the treated waters, it is not that much safe for drinking purpose. So we need further treatment. Yes, so the further treatment is what, disinfection. Okay, so we use some disinfectants again for the water from like from the rapid gravity filters, it goes to the disinfection process. So now there is again one numerical, same type of numerical as you have done for your slow sand filter. So here it is your, like it is told to design a set of rapid gravity filters. For population is 50,000, then rate of supply it is 180 liters per day per person. The filters again, it is rated to war 5,000 liters per hour per square meter, and you have to assume any necessary data which are not given. So like you have to first, since some datas are not given, then you have to like assume, you have to first find out the average daily demand, then you find out the maximum daily demand, as we already did in your slow sand filter numerical problem. So here they have directly found out the maximum water demand per day. So that is, we know that it is 1.8 times of your average daily demand. Yes, so they have directly just in they have put the maximum daily demand formula, that is it is same, it's 1.8 times of your this is your average daily demand. Yes, so they got it to be 16.2 into 10 to the power 6 liters, so that is 10 to the power 6 means it is million. So it is 16.2 million liters. So now they have found out the water demand, that is for per hour. If it is per hour, then you like divide it by 24. Okay, so since they got it to be 675 into 10 to the power 3 liters per hour. Okay, so the rate of filtration, now it is given in the question to be 5,000 liters per hour per square meter. Then again, now you have to, since you have to find out the length and breadth, so you have to know the area for the filter beds. So how to find out the area? So that is your water demand by rate of filtration. What is the water demand you got? It is 675. Okay, so this value, and the rate of filtration is 5,000 and you got it the area of filter beds to be 135 square meter. So here in the question you have to note one thing. It is given that you have to design a set of rapid gravity filters. That means a set is a 2. Yes, so you have to design two rapid gravity filter beds. Okay, so here you have to again now find out the area for each filter bed. So how will you find that? You have to like divide the surface area by 2. Okay, so then you will get the area for each unit as 67.5 square meter. Now the same thing, you go on with L into B is equal to A, that is area. Now they have told to assume something if some data is not given. So while doing the constructional details, so you will be getting that here for the construction of a rapid sand gravity filters, the length it can be taken it to be 1.5 times of breadth. Okay, so the breadth you will get to be 45 and sorry 6.75 meter, and the length you just 1.5 times of this 6.75 you will get to be 10. So the sizes are 10 meter by 6.75 meter. Okay, so very simple numerical. If you know one numerical slow and filter, you can do easily for the rapid gravity filters. Okay, so now next, there is one table for your comparison of slow sand filter and rapid gravity filters. Here, like after studying the both slow sand and rapid gravity filters, so you know some items are given on which they are being differentiated. So your the like here it is given like pre-treatment requirements. What are the pre-treatment requirements for slow sand filters? So here it's written like effluents either from plain sedimentation tanks or raw waters without any treatment are generally fed into them, and coagulation is not at all required for your slow sand filters. Here rapid gravity filters, coagulation, flocculation, sedimentation, it is a very important for your rapid gravity filters. For also like for base material, what are the gravel base, okay, what is the size of the sand, so all these things are written. Filter sand, what is the effective size of your filter sand, then what is the size of each unit. So based on these items, you know the differences are given for your both rapid and gravity sand filters. You go through this table also. It is easy, you just need to read once and you will remember. Okay, just you have to note down some things. Some MCQs might come from this table, so you have to study the table also. Okay, so now let's watch the video. Okay, for the constructional details you will be getting some idea about the constructional details of rapid sand filters. And if the video it gets end, if it in the middle of the class if it gets end, then you share your attendance in the WhatsApp group. Okay, you give your attendance there. Okay, so let me share the video. So this was all about your filtration part. Okay, so for next class we will be doing your this disinfection part. So now you watch this video.
So a lot more construction is same as slow sand filter, just a little bit tweaks here and there, and the base material is also same as what is used in the slow sand filter. That is, the base material uses gravel. So here it is also gravels, and in addition to the support, the sand on top of it, rapid sand filters, the gravel play a very important role in distributing the backwash water. Now this is something new, backwash water, and we'll be learning this in detail, that what is backwashing in rapid sand filters. The thickness is generally 60 to 90 centimeter of the gravel or base portion, The gravels are placed in 4 to 5 layers, each layer of 10 to 15 centimeter in depth. This is the same as how it was in slow sand filters as well. The coarsest gravels placed at the bottom and the finest placed at the top. Bottom gravels are generally 20 mm and top gravel 6 to 12 mm. All this is same as we had learned in the last video. Above the gravels comes the filter media. Again, this is also same, the sand filter media. So the filtering media is consists of sand layers about 60 to 90 centimeter depth. The effective size D10 of the sand varies from 0.35 to 0.55. Again, here the D10 material has to be used, that is the diameter less than 10% in the percentage finer cumulative graph. Coefficient of uniformity Cu is between 1.3 to 1.7, and sand is laid in layers where the topmost layers are of fine sand and the bottom is of coarse sand. Again, this is similar to the slow sand filtration. Now comes a very important part of rapid sand filters, that is the under drainage system. The under drainage system in slow sand filter, the under drainage system was provided to only receive the wash water, right? I'm sorry, only receive the filtered water, right? This part that you see here, the filtered water used to come and this part used to just receive the filtered water. But in the rapid sand filters, apart from receiving the filtered water, the under drainage system is also required to give the backwash water. So from under drainage system, this backwashing is done of the filter. Again, what that backwashing is, we'll see it a little bit later. It uh, it consists of manifold and lateral system in this central pipe called manifold, about 40 centimeter diameter, and runs throughout the lengthwise, and on both sides of the manifold 10 centimeter dia laterals are connected. Not exactly 10 centimeters, just a rough estimate. Again, this manifold is not only 40 centimeter, it's just a rough estimate, and the exact diameter will be based on the design, how we design the rapid sand filters. So this is that central manifold, central dia manifold, and these are the laterals, you see, and on top of it, now as you can see here, the water has to go get inside in this lateral, right? The filter water is going to come from the top, and that filtered water has to get inside this lateral, travel throughout, and then it will come in the central drain or the central manifold. So to get inside the laterals, the lateral should have some openings, only then the water can go inside. So these are the types of openings that your laterals are going to have. Okay, they are going to be at some particular angle, and the whole die is going to be 6 to 13 mm. This is one type. The other type is the lateral is provided with this strainers. These strainers are going to have those holes, okay, small holes, and from that the water will enter into the laterals. So either of these systems can be provided for the water to come inside the laterals. The area of perforations is equal to 0.2% of the total area of the filter. Now this is the total area of perforations. Okay, these are called as perforations, and the total area of perforations is generally 0.2% of total filter area. The cross sectional area of laterals is 2 to 4 times area of perforations. So first you will find area of perforations, from that you will find area of laterals, and cross sectional area of manifold is 2 times area of laterals. So first we find perforations, then area of laterals, then area of manifold. There is one more check that has to be done, that length of each lateral divided by the diameter of lateral, this should not exceed 60. This condition has to be satisfied. One more condition which has to be satisfied is maximum velocity in manifold for wash water is limited to 1.8 to 2.4 meters per second. These are called as troughs. Okay. Now the exact purpose of troughs I'll tell you. Let the water come in here, and this valve we have closed, so it will go like this and it will fill. Now this is when the filtration is being done. Okay, in this process we are doing the filtration, normal filtration process. So obviously this water is going to trickle down through this sand media, then it will be collected into the laterals. These are the laterals, as you can see. Then it will get collected in the manifold, and from manifold it is collected outside. The filtered water is collected outside. So this is a general process of filtration in rapid sand filters. Now comes the part of wash water or backwashing. Why backwashing is done? Backwashing is done because these uh, sand or the filter media gets clogged very easily. So to keep the efficiency of this filter, the that filtering media has to be washed. Now how it is washed is that you close this uh, wall, you open this wall and you close this wall, and there is a tank which stores the wash water. This wash water is clean water. Okay, means we are going to clean our filtering media with clean water only, and it can be some part of the filtered water that had come here. So the filtered water that had come here, you can store some part of that in this wash water storage tank. Now just look at this process.
Acha, are you being able to hear the video? The audio of the video, can you hear? Everyone? Yes, others can hear. I don't know why this Atul Tatar and they can't hear. It's okay from my side. Okay.
So it will go through the central manifold, then into the laterals. Okay, then it will fill the laterals, then it will go upwards. Now the journey of the water is going upwards, and when it reaches here, let us just see it again. So when it is going upwards, it will fill, and when it reaches this trough area, it is going to spill out, and from here it is going to get collected into what is called as wash water gutter. Okay, so this water that has come out has all the impurities that were collected in the filtering media. So what is happening, this wash water is coming like this, and first it is going through the central manifold, then it is filling the laterals, then it is going upwards, and when it reaches this top part of your trough, it is spilling out, spills out. So this is nothing but the side view of this trough that I have shown here. Okay, those are called as wash water troughs. We will see a short video on how that backwashing is happening. See, this is the filtering process that is happening. These are those troughs. Yeah, these are those troughs that I was talking about. All the troughs that are being placed. This is the filtering media that you can see from the top, and now the backwashing process is going to get started. So you see all this water that came up, that is your backwash water, and this water, as you can see, is not clean, it's a dirty water. So that dirt, it has taken out from the filtering media, and it is going to get collected to your troughs, and then finally it goes. And you see how this water is now turning clean, as and how your So filtering media gets cleaner, the backwashing water will also get clean. So this was the process of your backwashing.
Is your cleanser doing enough for your sensitive skin? Give your skin complete care with dermatologist recommended Cetaphil Gentle Skin Cleanser. It defends against
Process of filtration in rapid sand filters. Now comes the part of wash water or backwashing. Why backwashing is done? Backwashing is done because these filtered water upwards through the beds such velocity that it causes the sand bed to expand to about 25 to 40% of its volume. Now it is very obvious that if you pass the water through a sand, if you forcefully pass the water through a sand, it is going to expand in some volume, right? Due to this, the grain moves and rub against each other and they clean themselves. Backwashing is usually done when the head loss measured of filtered water reaches 2 to 3 meters, indicating that the sand has become dirty and because of more frictional losses. The backwashing is done at a high rate of about 300 to 900 liters per minute per square meter, that is 6 to 18 times the filtration rate for about 15 minutes. The backwashing rate is determined on the basis of that backwashing velocity should not exceed the settling velocity of the finest sand particle, generally 0.3 to 0.9 meter per minute. Otherwise, backwashing may deplete the filter media. This is also very simple to understand, because if the backwash water has velocity higher than the settling velocity of the finest particle, then it will take that filtering media along with it, and that filtering media will be lost. So this is not what we want. We want our filtering media to be retained, only that it has to get cleaner. The amount of water required for backwashing may be 2 to 5% of the total filtered water. So as I told you earlier that the total filtered water that we are going to get, this backwash water can be 2 to 5% of that. Sometimes air compressors is also required during backwashing of the sand grains are agitated by the jet of water or by compressed air. So this agitation of the sand grains are required because while filtering, those sand grains become very they settle, and they are set they get set very easily. So this backwashing water cannot clean it thoroughly. Sometimes it happens. So this air compressor is required so that those sand particles can get separated out first, and then the backwashing water can easily clean it. Due to this, the grains are separated and facilitate for easy backwashing. Now, what is this wash water trough? How to design the wash water trough? Generally, this V-shaped bottom wash water trough is provided. It is
Okay, so the design part it is not needed, okay? Just I have tried to show you the animated part of the construction details of the rapid sand gravity filters, okay? So, okay, I hope you have understood the filtration of both slow sand and rapid sand gravity filters. So, next class we will be doing disinfection. Okay, okay, then you sent your this one enrollment IDs for in a WhatsApp group. Okay, thank you.